Welcome. This is IB Physics, and I am Mr. Tompkins, and we're going to start mechanics. In this video, we're going to talk about one-dimensional motion, and we're going to cover that entirety in this video and in this lesson. It is now midnight, and I am recording this. Hopefully, it all goes well. So the first thing we're going to talk about when we talk about one-dimensional motion is, well, what is motion? And motion is whenever an object changes its position when we measure it from a stationary reference point. Now this word stationary right here, it's in quotation marks because we have different ways or different reference points that we look at depending on where the object is at. If we're on the Earth, we usually assume that the Earth is stationary. But if we're in the solar system, well then we usually assume that the Sun is stationary. And then as we go on further out to look at the galaxy, we assume that the center of the galaxy is stationary. But we have to understand that this reference point is something that's arbitrary and something that we get to pick. And we'll cover relative motion in the next lesson. Let's go ahead and define what the position is. And the position is just a location of an object. Either that is a Cartesian coordinate on a grid coordinate, or it's a relative position measured from that stationary object. And we usually give it the variable x. Now some things that we have to think about is that IB Physics has a different convention for variables than we had in Physics 1 or Physics First. And that is some of these that we've already seen, such as displacement delta x. In IB Physics is actually going to be an s. The initial velocity, which is v sub I, in IB Physics is going to be a u. And the final velocity, which is v sub f, is now going to be just v. Now before we can start talking about motion, the most basic level is displacement and distance. And these are often terms that get confused easily, so we're going to go ahead and compare them and see how they're different. Distance is the length of the path between two positions. So as an object moves from one position to another, we look at the length of the path that it takes. We give it the variable d, and because it's a length, lengths are always positive, and so this must be a scalar. The units are the SI units for meter, which is the SI units for length, and that is also the same for displacement. Displacement, on the other hand, is a straight line distance between 2 points, or two positions. It starts at the initial position and ends at the final position. We give it the variable s, like I said before, and we find that by taking our final position and subtracting our initial position from it. Because it is a straight line distance, it can point in any direction that it needs to, and so this makes it a vector, and the units again are meters. So here I have an example of a dog, and I watched this dog scoot its butt across the yard, and it started here on the left, and then it followed the black path all the way down and around. And for some reason my PowerPoint cut off the arrow there, and so you see this little red line there. But this red line represents the displacement. It starts at the dog's initial position and points in the dog's final position. So the black path is the distance the dog traveled if I were to measure that with a meter stick, and the red S, if I were to measure that with a meter stick, would be its displacement. Okay. So let's move on. We have an example problem. Go ahead and write this down and work it out with me so that you can understand how we calculate displacement and distance. So we have a dog that walks 40 meters. Hold on, I gotta fix this here. Put this on black. Alright, there we go. So we have a dog that walks 4 meters east. Alright, so let's go ahead and draw that. He walks 4 meters east, 4.0 meters, and then he walks 3.0 meters north. Now I like using 4.0 and 3.0 because it makes a very nice triangle, and this is one of those special triangles that I could say is a 3, 4, 5 triangle. Alright, and it makes it very easy to calculate the hypotenuse. You will not see this in normal everyday life or normal everyday physics, but in this case it'll make the calculation so much easier. So what is the distance the dog walks? Well, the distance is just adding up all these different legs. So I add 3 meters and 4 meters, 3.0 plus 4.0 and that gives me 7.0 meters. So that's the distance the dog walks. That's the length of the path. But what is the displacement? Well, the displacement, on the other hand, is going to be the final position minus the initial position, or my change in position. And so in order to do this, I have to figure out, well, here's the initial position, here's the final position. And so I have to figure out this length. Now this is, like I said, a 3, 4, 5 triangle, which makes it very simple to calculate. But just so that we know, the displacement is going to be the square root of 4.0 squared plus 3.0 squared, which gives me 5.0 meters. Okay, that's the first part of displacement. Now there's the part that we have to think about, and that's this angle here. We have to figure out its angle. Now in order to figure out the angle, we look at the inverse tangent of the two sides. Now tangent is opposite over adjacent, so we want to look at inverse tangent of 3.0 over 4.0, and that's going to give me an angle of 37 degrees. But wait, I'm not done. Remember the reference statement. I start here going east, and then I go up north from it. Okay, so I need to look at what's my reference statement. Well, I start east and I go north. So it's going to be 37 degrees north of east. So if I were to write this all out, I would say the dog went 5.0. The dog's displacement was 5.0 meters at 37 degrees north of east. And that would be the displacement of the dog. All right. That was an easy one. Let's go ahead and move on. So now we're going to talk about speed and velocity. These are another two terms that often get confused, and they are different in the physics world. Speed is the rate that the object follows the path. And so it's a scalar quantity, and it's found using distance. Velocity, on the other hand, is the rate and the direction of the object's position change, which means that because it has that direction, means that it's a vector quantity. And this is found using displacement. They both share the same units, which is meters per second. And in IB physics world, we draw that as ms to the -1, because the -1 exponent means that that s is on the bottom, and it's by itself. The equation for speed is distance divided by time, and the equation for velocity is displacement divided by time. So the equations are different. So let's talk about this example problem again, and let's go ahead and erase. And let's start over. So here it takes the dog to travel, the last example, 2.5 seconds. What is the average velocity and the average speed? Well, let's start with velocity, because that's first. So we want to know the velocity of the dog. Well, I know his displacement is 5 meters, or 5.0 meters. And I know the time it takes is 2.5 seconds. And so 5 divided by 2.5 gives me 2.0, because there's two significant digits, ms to the -1. Now, because velocity is a vector, which I'll represent by this arrow here, that means it needs to have a direction. The velocity direction is exactly the direction of the displacement. All right, come on, right. There we go. Okay, it was too close. So now we need to include the direction. So this is going to be at 37 degrees north of east. Okay, so that's the object's average velocity. Now his average speed, on the other hand, is going to be speed is going to be distance divided by time. And so the distance that he traveled was 7.0 meters, and the time is 2.5 seconds. And so his speed, on the other hand, is 2.8 meters seconds to the -1. and it is a scalar quantity, so I do not need to include the directions. Okay, let's move on. Now, acceleration is another term that we need to be familiar with, and that is just the rate that the object's velocity changes, and it's given by this equation here. Acceleration equals the final velocity minus the initial velocity divided by time. If I were to break this down into variables, a, which is the variable for acceleration, equals my change in velocity divided by my change in time, or my final velocity, v, minus my initial velocity, u, divided by delta t. It is a vector quantity that points in the direction of the change in velocity. And the units are meters per second squared, or ms to the negative 2. Here's another example. Let's go ahead and do this one. The dog then slows down to a velocity of 0.5 meters per second to the negative 1 in 2 seconds. What is the acceleration? Well, in this case, we have our velocity as 2.0 meters per second to the negative 1 at 37 degrees north of east. So that's his initial velocity, his final velocity, so u equals 2.0 ms to the negative 1, and my final velocity v equals 0.50 ms to the negative 1. Okay, what is his acceleration? And t equals 2.0 seconds, and acceleration is my question mark. I want to know, what is his acceleration? So I'm going to look at this. Acceleration is it equals my final velocity, which is v, minus my initial velocity, which is u, divided by delta t. Okay, and this is actually delta t. It's the time period. So my final velocity is 0.50 ms to the negative 1, minus my initial velocity, which is 2.0 ms to the negative 1, and all of that divided by 2.0 seconds. Now, if I were to take a half and minus 2 from it, I'm going to get a negative 1.5 ms to the negative 1, and all of that divided by 2.0 seconds. That's going to equal my acceleration. So now, how many times does 2 go into 1.5? Okay, so it's going to be 0.75. There is a negative sign on top, and a negative divided by positive gives me a negative. And this is now going to have the units ms to the negative 2. Okay, good. So I know my acceleration, or the magnitude of my acceleration, which is 0.75 meters per second squared. But now I need to figure out, well, in what direction. This negative sign means that this is the opposite of the direction that I have up here, which is 37 degrees north of east. Now to flip this around, so let's assume that this is 37 degrees. And if I were to draw my coordinate system here, well, then as this goes through, these are opposite angles. And so that this means that this is 37 degrees. And so the opposite direction is going to be 37 degrees. Let's go ahead and write this down. 0.75 meters per second squared at, and then 37 degrees again. But we want to go the opposite direction. So this is going to be, instead of north of east, it's going to be south of west. South of west. There we go. So the acceleration of this object, or of the dog, is 0.75 meters per second squared at 37 degrees south of west. All right.